So today we'll learn about Python. Welcome. Now, Python is one of the most popular languages to learn right now. So you can access Python by just going to Google and just type in Colab. Google has this place called Colab where it's a programming environment where you can type Python code. You don't have to really download anything. It's just accessible. So I already have a program called Earthy, and you can see how Python is structured. You have different code blocks. So the first code block, I just have a bunch of references. These are just calls to bring in some different libraries. In the second code block, I have some instructions and some declarations. So you can just run each code block independently, but you have to remember that all previous code blocks have to be run before you run successive code blocks. So let's just add a code block and see what it does. I already defined E, so don't worry about that too much, but here you can print out E, the value, and it prints out 29. Or you can do operations on different things. So let's just use an example such as square root of E, and that should give us a good value. And right now it's thinking a lot, so you really start to get worried a little bit, don't you? And boom, it should come up, and it's an error. What happened? So what you can see here is we didn't type in math. You need to type in math dot square root. Then that's the proper command, and we type it and we enter and we get 5.38, which is square root of 29. Great. Okay, so now we can just delete that code block, and we can go on to our declarations and see how everything's structured. And we come across these lat longs, and it looks like an array, these brackets, these square brackets. So what does that actually mean? How do we access those values? So let's just use an example. So we just declare a lat variable or array, and we have 12 and 123. So what happens if we want to access 12? We can just put print lat in the first element, 1 in brackets, and we press enter, or we run the code, and we get 123, which is the second element. So there's something wrong. As we know, all arrays begin with the index 0, so you have to use the index 0 to access the first element, and index 1 to access the second element. Always remember that. It's a very important programming tip. And so we have some conversion factors like kilometers to feet. We have lat long, where we're going to save our latitude and longitude coordinates, because we're going to write a program that basically calculates the distance from one location to another location. So for one city to another city. Okay, so we're going to just see, what does coordinates mean? How is it structured? First of all, we want to do a little research. So we can just type in an image to see if there's anything that gives us an intuitive understanding of how latitudes and longitudes work. So we can see they're divided by degrees. So 180 degrees to the east, 180 degrees to the west. Okay, great. So essentially it's like a coordinate plane. It's like an XY coordinate plane, except that you use degrees, and you have like 180 degrees and you have 90 degrees. So that's pretty easy to understand. To the left would be negative. To the south of the equator would be also negative, because as we know, if you look at a complex plane, if you go to the left of the center line, you go negative, and if you go below the center line going horizontal, you also go negative. So we just need to get a little bit more information about the Earth that we live on, the planet Earth. So let's just type in circumference, if I can spell circumference right, and circumference of Earth. And we want to see some words here. So 24,901. Okay, let's see what that is in kilometers. 40,075. So it's about 20,000, right? So we can just round it off. 20,000 divided by 180. So each degree is is our convert value. We won't actually spell it out. We can just leave it as an expression. So 20,000 kilometers divided by 180 degrees gives our number of miles for each degree. And we want to look up New York City. That's going to be our first location. So let's just go back, and Google told us that the latitude and longitude of New York City is 40.7, and what was it again? 74? If I can remember correctly, 70. Let's look. Okay, 74. 7.4.0060. There we go. Okay, and we just put a negative sign because it's west of the prime meridian. So next we want to look up Boston. Okay, Boston, Massachusetts, 42.36. So we just plug that in. That's going to be our second location. So we're putting in the second position in the array. And we're going to look up Boston is 71.05, and that's west or left of the center axis, the vertical axis. So it's going to be also negative. So once we get that in, we're just going to plug in a little negative sign. And we should be good. And we want to just do a double check, because is latitude west or is latitude north and south? Is it east and north? Okay, let's see what Google says. Longitude east and west. So longitude seems to go on the x-axis. So we have to change a few things. What we did is we put latitudes on the wrong axis. So let's just see. Okay, yeah. So yeah, we can see the west is the 71, so that should be longitude. Okay, so all we have to do is just change that around. No big problem. Okay, there we go. Okay, now so essentially what we want to do here is do like the distance formula. If you know what a distance formula is on any kind of coordinate plane, is like x1 minus x2 squared plus x, like y1 minus y2 squared, and you take the square root, and that will give us the answer as far as your distance from one location to another location on a coordinate plane. Let's just take this out. We don't need this print statement right here. Okay, there we go. Okay, and as you can see, the distance is equal to that distance formula. That's a standard formula you're going to have to know in every single geometry course, every single engineering course, everywhere. And one of the most popular or important formulas in mathematics and engineering. Okay, so now we have, let's just run this to make sure we have everything up to date, because we changed a few things right around here. And okay, now let's look. Okay, so they say we have 1 million feet from Boston to New York, but we don't really know how to convert 1 million feet to anything we can use. So let's try to do miles, right? So there are 5,280 feet in a mile. And let's change that to miles to get the right display. Now we can choose all. And there we go, 233 miles from New York to Boston. So we've actually accomplished something. Using the latitude and longitude coordinates, we were able to calculate the number of miles from between two locations. And just to check that, we just do Google map directions, and we have 225 at the most, and this is like 233, so it's not too bad. I mean, it's a rough calculation. It's not a driving distance. It's like, it changes a little bit, and plus we're just using a flat surface. We're approximating. But to just make sure we can kind of calibrate this, or make sure that we have the right calculation in perspective, we want to throw in something that we already know. So we want to throw in, let's say 180 to negative 180. So this would be the circumference of the Earth, or pretty much half the circumference of the Earth. And, well, actually the whole circumference, because 180 to a negative 180. We trust Google, but we also have to verify. Okay, so it gives us number 24,854. So we want to see if that is the circumference of the Earth. And so we type this in, circumference in miles. How many? 24,901. That's pretty close. But how about from, how about from north to south? Because if we get that, we can quit right now. We're done. So let's see, north. Type in north over here. South, and we get 24,856. Close enough. We're good. Yes. Okay. Hopefully you enjoyed that. That was your first Python program. Bye. So today we'll learn about Python. Welcome.